Section 3.1 is titled Derivatives of Polynomials and Exponential Functions, but we'll actually end up learning a little bit more than the title suggests. Let's say we want to find the derivative of the function f of x equals 3x to the fifth plus 9x squared minus 1 over the square root of x. So far, the only tool available to us is the limit definition of the derivative. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now, f of x plus h is simply f of x with x replaced by x plus h. So, f of x plus h is equal to the expression that you see here. And f of x is, of course, the function that we were given originally. Now, we can't compute this limit simply by plugging the point h equals 0 into the expression inside the limit. If we did, we would end up with a 0 in the denominator, and division by 0 is not allowed. So, to compute this limit, we would have to start by simplifying the expression inside the limit. This is a fairly daunting task. For example, one of the steps would have to be to expand out the power x plus h to the fifth, which is already quite a bit of work to have to do by hand. At this point, you might be wondering, are there any shortcuts we can take when computing derivatives? The answer is yes. There are shortcuts called differentiation rules that can help us differentiate faster. We will learn some of these differentiation rules next. Let's begin with constant functions. On this slide, we'll consider the function f of x equals c, where c is a constant. In this case, the graph of f of x is the horizontal line y equals c. To find the derivative of f of x, we can use the following important feature of the derivative. The derivative of a function at a point gives the slope of the tangent line at that point. Let's see how we can use this property to find the derivative of the constant function f of x equals c. Let's start by looking at the graph of f of x. You should ask yourself the following two questions. First, what does the tangent line to this graph look like at any given point? And second, what is its slope? The answer to the second question will give you the derivative of f of x. You should now pause this video and use the hints that I gave you to figure out the derivative of f of x equals c. Once you find f prime of x, please record your answer in question 1 of the class prep assignment.